Hello and welcome to our Data Umbrella webinar. I'm going to do a very brief introduction, about 5 minutes, and then Mariatta will be doing her talk. And what you could do is put any questions you have either in the chat or the Q&A, and at the end of the session, Mariatta will answer it. This is being recorded and it will be placed on the Data Umbrella YouTube, and I will share a link to that YouTube in the chat. Data Umbrella is a community for underrepresented persons in data science, and we are a volunteer-run organization. A little bit about me: I'm a statistician, data scientist. I have a background in statistics and a business degree. You can find me on Twitter, LinkedIn, and GitHub at Reshama. We have a code of conduct. We thank you for helping make this a welcoming, friendly community for all, and that applies to the chat as well. There are various ways that you can support Data Umbrella. The first and foremost is to follow our code of conduct and contribute it to making it a space where everybody wants to be in and return to. We also have a Discord where you can ask and answer general questions there, share events, share jobs if you'd like, and the link to Discord is on our website. Another way that you can support Data Umbrella is by donating to our Open Collective. We have all of our videos from the past year and a half on YouTube, and one of the playlists we have is contributing to open source, and so we have done webinars on Pandas, CorePython, Scikit-learn, NumPy, so feel free to check that out. We also have a career advice playlist, and we've had 4 really excellent speakers, so if you have a lot of FAQs on career, definitely check it out. And this is just a sampling of some of the events that we have had over the past year and a half. We also have a job board. It's at jobs.dataumbrella.org. I will also put a link in the chat to that. And it is free to post jobs. So if your company is hiring, feel free to post. And if you're looking, feel free to check it out. The website, dataumbrella.org, has a lot of resources that I have personally compiled. There's a list of community conferences. There are guides to using inclusive language about accessibility and responsibility. And so, I'd recommend checking that out. We are on all platforms as Data Umbrella. The ones that I've highlighted are the ones that we use the most frequently. So Meetup is the place to go for all of our upcoming events. That's the one place to subscribe to. We also share events on Twitter and LinkedIn. I mentioned Data Umbrella and Job Board, and we also have a monthly newsletter, which I will also share the link to in the chat that you can subscribe to. We have a couple of upcoming events. The first one is on November 11th, and it's getting started with Python for data science. Mina will be the speaker, and it will be about an hour of webinar format, and then we're going to go over to Discord for about half an hour to do some hands-on exercises. And that event will soon be posted publicly, but keep that in mind if this is something you're interested in. We also have another webinar coming up on November 18th, which is Visualize Your Pandas Data Frame with Zero Effort. And Lux is, it's a new library based on Seaborn. And this is a research project that has come out of Berkeley Institute for Data Science. There's a lot of great research projects that are out of that institute. And so we're really looking forward to having Doris speak on her library. So today's talk is with Mariatta. It's Intro to Unit Testing and Continuous Integration. And a little bit about Mariatta. Mariatta is a Python core developer, which is really, it's a real accomplishment and a contribution to the community. Python, that language that was founded, that is used worldwide. She's a staff software engineer at Uplight. She is also a Vancouver PyLadies core organizer. She is one of the founding members of the PyCascades conference, which, by the way, the CFP is open for that conference. If you just go to a search engine, the CFP closes on Sunday, October 24th, if you're interested in speaking at a conference. She moved to Canada almost 2 decades ago and now lives in Vancouver with her husband and 2 children. And if you follow Mariatta on Twitter, you will see that she has daily typos, which are quite amusing. And so in her free time, she contributes to open source, builds GitHub bots, and fixes typos. And these are, you can find Mariatta on LinkedIn, Twitter, and GitHub at Mariatta. And with that, I'm going to turn off my mic and camera and hand the stage over to Mariatta. And just a reminder, if you have any questions, just put them in the chat and we will get them answered.
All right, thank you so much, Reshama. How do I make sure you all see my screen? I'm not sure.
There's a slight delay, so if you hit the screen at the top, it'll take maybe 10 or 20 seconds for it to go into place.
I think I still see your slides. Is that correct? Or let me, let's see. Share. All right, do you see my screen now?
Right now, it'll be just another couple of seconds. Yep, now we can see your screen.
Okay, great. Let's see. Okay, yeah, hello everyone, and thank you so much for joining me today, and thank you Reshama and Data Umbrella for having me to talk to you about unit testing and continuous integration. My screen's not advancing. Okay, and yes, my name is Mariatta, and I live in Vancouver, Canada. You can find me on Twitter and GitHub as Mariatta, and I work as staff software engineer at Uplight. We are hiring, so check it out. And in my free time, I contribute to open source projects. I maintain open source projects, and I'm one of the Python core developers, which means I'm a maintainer, one of the maintainers of one of the most popular programming language out there. So unit testing is very important. You should do it. If you're a developer, an engineer, if you write code that will be used by other people, if you have code that will go to production, then you should write unit tests. And this is non-negotiable. And I know that you're not gonna start writing tests just because I told you to do it. You wanted to understand why this is important. Like everybody probably already told you you should write tests, but sometimes the benefit is not too clear. And to be honest, I was the same way. In my first job as professional programmer 15 years ago, we didn't write tests. And I don't know why. I joined a team, I was a newbie. They didn't write unit tests. Does not mean we did not test our software. Our idea of testing at the time was we deploy the system every few months. We would go through every single functionality, try it out, everything. We have actually a big document that we print out like 100 pages long. It describes the features, the workflow we're supposed to have. We have to do what's written there, say, if we click this, something happened. And we have to tick the box saying, yes, it works. So that was how we test back then. It's a boring thing. It's what I described was manual testing. It's boring, and back then I remember the senior programmers who were there before me. They said, "This is so boring. We let the newbies, the interns, do testing." And I felt it's not right. We shouldn't be doing manual testing like that. I mean, maybe we will test it once manually, but we shouldn't be doing it repeatedly. It's boring. We didn't have to do that 100 times just to be sure that the code works. So writing unit tests is a way to automatically test that your code works. You write unit tests for the same reason you do manual testing. You want to check if the code actually works. So let's look at this example. Say I have this function that's very simple. It's like 2 lines of code. I call it add 2 numbers, accepts 2 parameters, and I just add it up. It's very simple. So how would you test this if you don't have any kind of unit test? Well, you would run it. Like you would call the function, print it out, you read the output and verify that, yeah, indeed 1 plus 2 equals 3. So now you know it works. So that's the manual way of testing. Programming language like Python comes with its own unit test framework for you to write automated unit tests. The unit test module is built in Python. So if you have Python, you can just import it and start defining test cases. So in the test case, import the unit test module and start importing the actual function, the code that you wrote. So in this case, I have the add 2 numbers function. So I'm going to import that function in the test file. Call the function, pass the proper parameters, and then I write, and to test the function, I would make something called an assertion, saying assert that the result, the output of the function, will be equal to value I expect. In this case, if I call the add 2 numbers, passing 1 and 2, I expect the result to be 3. And then I would run the test in the prompt by saying python-m unit test and the test file. So the test add number, it will be run. It will say there's one test that was run and it looks okay. That it means the test is passing. So I'll show you an example of running a test where the test failed. Here I change my test by saying instead of expecting that 1 plus 2 equals 3, I wrote in my test that 1 plus 2 should equal 12, which is wrong. So this should fail. So when I run the test, I will see assertion error. It says that the value I expect, 12, does not equal the value returned by the function. So it failed, and you will see like an error message outputted by the unit test. So in this case, I should be looking at my test and my code to figure out, was it the code that was wrong or was it my expectation, my test that was wrong? So this is another reason you want to write unit tests. Like you want to test your code against various inputs and scenarios. Maybe you want to test whether your code can handle, things like negative numbers, decimals. You can write different unit tests, different test cases for those situations. The other reason you want to write unit tests is to be able to find bugs early, bugs with your code. Because as you write tests, you'll be thinking about various inputs, scenarios, and edge cases. Maybe you even discover bug while testing, and you can therefore fix your code to be more reliable. So using this same example, maybe I started thinking, what if I pass letters like A and B instead of numbers? What is the expectation here? As a developer or as the programmer, I should know what I expect. Do I want to allow this function to pass, or should it return me AB? A plus B is AB. Is that okay? Or do I want to raise an exception? Like, do I want to not accept any letters? People should be passing numbers. So those are the decisions that I would have to make. So and what if people passing in different values that you didn't expect? Say if one of the input is a number and the other one is a letter. Again, what is the expectation here? This code will raise an error. So you may want to go back to your code. Maybe you want to even write the logic to handle this kind of input. And if your code raises an error, then you can actually test for the error that gets raised. So in this example, I went back to my code that I wrote earlier. So I said now that I only want to accept numbers if people pass in letters like A and B, I want to raise an error. So once I raise the error in the code, I will then adjust my unit test to say that, instead of accepting values, I want to make sure that a certain error is raised. In this case, you saw that I wrote something like assert raises instead of, assert equal earlier. So this is the way to say that I'm expecting this function to raise an error with these parameters. So writing unit tests will help you discover issues like this during development, and it will even help you improve your code to be more reliable. Your unit tests actually work as a documentation about your code. It gives information and examples of how to use your code. So if somebody else is reading your code base, like if they're new to it, they're reviewing your code and wanted to understand what it does, want to see some examples, the best way to do that is by reading the unit test. And I do this myself when I wasn't sure, like there's a library out there, they didn't have actual documentation. How do I use it? I would go and check if they have unit tests. So they could see the code is used, how to call it. They could even see different test cases and understand the constraints and limitations of your code. So writing unit tests seems tedious. Like earlier, I initially wrote only 2 lines of code, but I ended up with 5 times more code in the form of unit tests. But this is actually important. Having unit tests will help when it comes the time for you when you want to modify or do some maintenance to your code base. Just here's an example. Say the new Python is now out. Maybe I've been writing my code in an older Python version. And now that we have, say, Python 3.10, I want to know if my code will work with the new Python. And in order to find out, I would run the test. Just test my code against the different Python environments. If my test pass in all of them, then that's great. And if pass in certain environment but it failed in 3.10, that means there's incompatibility. And if I want my code to be updated, I need to fix those tests. I need to fix my code to make sure that I address the changes. And in your tests, you can use your test to catch deprecation warnings. So basically in Python, sometimes we would remove functions in future versions. And the policy is we will give you a deprecation warning when you use the function that's going to be removed. And we will tell you we have at least two releases. Say if we issue a deprecation warning in Python 3.6, we will keep it for at least 3.7, 3.8, and it could be removed in 3.9. So you have time to address such changes. So you can catch this kind of warnings early in your unit tests. So you can pass in the -w flag when you execute the unit test to see all these warnings so that you can decide how you want to move forward. Like you may need to adjust your code. I've seen patterns where people would just check if something like if their Python version is 3.8, execute this path. If it's 3.9, execute something else. So those are some strategies when upgrading your Python. And another reason why you want to write unit tests is so that you can have continuous integration as part of your process. Continuous integration is the practice of using automation to frequently integrating and merging code changes into a single project. So let's talk about continuous integration. Continuous integration, or CI for short, is considered DevOps best practice. You should do this, especially if you work in a team. If you open source your code, you have collaborators, you have more than one contributor. You should have CI as part of your process. And again, I'm sure you're now asking me, why is this important? Because integrating code, merging code changes is actually costly. It takes time and effort. Worse, you could be introducing bugs. It could break existing functionality. So instead of thinking about why do we need CI, let's think about what if we don't have CI. So imagine you're in a team. You're working on one feature, your coworker working on a different feature independently, and while you're still working on your own feature, your coworker finished and said, "I made a pull request. Can you review it so we can merge it?" So now you are tasked with deciding and reviewing whether you want to merge this code. How do you decide? You will review it, you read the code, and then you're gonna start asking questions about this code. You wanna know, does the code work? Does it do what it's supposed to do? Maybe you'll read the requirements and ensure everything is implemented. You're gonna ask, okay, what are the constraints? What are the limitations about this code? Does it handle exceptions? Does it cause exceptions? Does it break anything else? Is this compatible with the rest of the software? So how do you answer all these questions? You can just take the code, try it out, and run it, right? Manual testing. Or you check if they have unit tests that cover all of this. And then not only they have to have the test, you probably want to actually run the test yourself and see that the test is running. But running the test is not straightforward, especially this is somebody else's code. You first need to get a copy of the code that your coworker wrote into your local machine. You need to set up local environment, install dependencies, which is not an easy thing. I have to set up local environments for various open source projects. Each of them takes time. Then you get to run the test and wait for it to finish and view the result. Then you want to do it all over again for the next pull request from another team member. And you do this because you want to be certain that you're building and delivering code that meets the quality standard. Merging code is costly and risky. In order to be more agile, to speed up the development cycle, you need to automate this process. So if you have a CI, you can have a process that will automatically grab the copy of the code changes. There's the process that can automatically set up the necessary environment to run the test. And then it can even run the test automatically. All you have to do is now just ensure the CI ran and that the test passed. So now you can click the merge button. And there are various ways to add CI as part of your process. There are lots of options, and depending on your platform, if your code is hosted on GitHub, then you can use GitHub Actions. If you're on GitLab, then you can use GitLab pipelines, and there are various SaaS like providers that do this. Like you can use Circle CI or Travis CI. So I'll give an example, a little bit of short walkthrough on how to set up a CI using GitHub Actions. With GitHub pipelines, it will work similarly, but maybe they have different ways of configuring. But the concept will be the same. So on GitHub, you can set up the CI using GitHub Actions by adding a YAML file. The YAML is yet another markup language. So basically, think of it as the configuration file. This is basically a set of instructions to tell the CI on how to set up, how to run the test for your project. So the YAML file has to be added under the GitHub workflows, GitHub/workflows directory. So I have an example repo. Actually, you can go through. The link is there in the slides. So github.com/mariatta/sample_ci_repo. So you can see how I set up the CI using GitHub Actions. This is just a short snippet of how I set up the GitHub Actions. So if you look at the lines where it says steps and it says I install the dependencies, I want to install pip and coverage. And then I run the test, which is python-m unit test, which is the same command I use if I want to run my test locally myself. Then you probably notice that there is a line that says python-version equals, Python 3.8, 3.9. This is where I'm telling the CI that I want my code to be tested against the different Python versions. So remember earlier when we talked about the importance of unit tests, I want to make sure that my code is compatible against various environments. In this case, I'm letting the CI to set up all of this environment for me, so I don't have to deal with having to install different Python versions myself, which could be a mess. It's not easy. Um, so this is how CI could help you. I can do more with CI. It's not just for unit tests. You can run other things. For example, if part of your measure of quality for your code base is that you follow a certain coding style, if you use Pylint or Flake 8 or black formatting, and you want to make sure that the code that is committed complies to certain standard, you can include those as part of this CI as well. So in this example, I choose to use black, so I would use the black -- check just to make sure that the code being merged will comply with black, which is an auto formatting tool in Python. And you can, if you use Pylint, you can execute the Pylint command in here. So in this case, in this example, the steps basically I'm telling the CI install the package, like install black package, and then run the command. I can use the CI to check for code coverage. So here I showing an example on how to run the unit test and then produce the coverage report. So these tests will automatically be run whenever anyone makes a pull request to my repository. So whenever anyone wants to make changes to this code base, since I wanted to ensure of a certain quality standard, I wanted to make sure that these checks are passing before I would merge it. So now that I know the code works, I know it doesn't break anything, it follows proper coding standard, I can now merge it confidently. So that's about CI. And I know I've only been given you very introductory examples and topics on unit testing. And there are lots of resources out there for learning more on how to write unit tests. Maybe you should start with the unit testing documentation at docs.python.org. There is a pretty good introductory tutorial about unit test module on YouTube by Corey Schaeffer, so you can look into that. There is a really good in-depth article about unit testing on real Python as well. And you will need to start doing integration testings or testing with third-party applications or third-party system or API. You may come across the concept of mocking when writing your test. So Python does come with its own mock object library that you can use for this purpose. So what is mocking? So early on, I mentioned that the reason you write tests is that you can test that your code works. You call a function, make sure it does what it's supposed to do. When you have code that interact with external systems, maybe you work with API, or for example, if you're developing, say, a point of sale system, like you have maybe a cashier, you have an UI, and then you have cash drawer, you have credit card machine. Maybe when you test, when you test this kind of functionality, you may not want the cash drawer to be opened each time you run the test. You also don't want to be charging credit card all the time whenever you run the test for like payment processing. So in this situation, in your test, you would want to mock the calls to those external systems or those third party. So basically you would fake the call to those systems instead of actually calling them. So mocking and patching are actually very powerful tools in unit testing. There are really great tutorials on those as well. So there is an article from Real Python, Understanding the Python Mock Object Library. There is a great talk by Lisa Roach from PyCon US a few years ago called Demystifying the Patch Function. So I do recommend these resources. Another useful testing framework is PyTest. So this is a third-party library that you will need to install it separately. It is quite powerful testing framework. I do recommend it. I personally use it in my open source projects, and we use it at work as well. So there's a great tutorial on this topic, Introduction to Unit Testing in Python with PyTest, which was given at PyCon US by Michael Tomwing and Christy Wilson. And once you have unit test and integration test, you're eventually going to need to do end-to-end testing. So in end-to-end testing, you're not only going to test just a single unit of code, not just a function, but the entire workflow from start to finish. And there's a really great tutorial from Free Code Camp that explains in detail about this topic. So now that you learned about unit testing and continuous integration, you understand the importance of those, you should do it. Go now, go write unit test, have 100% test coverage, have CI in your workflow. So thank you so much for listening to my talk. And thank you again, Reshama and Data Umbrella, for having me here. And then if you'd like to get in touch, you can find me on Twitter as Mariatta. And if you rely on Python in your day-to-day work, I suggest you sponsor Python on GitHub. You can sponsor me on GitHub as well. My sponsors help me keep motivated into continuing doing what I do. So thank you so much.
Mariatta, thank you so much. That was amazing. I learned so much in that presentation. Oh, I have no idea why I'm going to turn the video off. Yeah, I don't know what's going on. So, hey, everybody, if you have any questions, please put them in the chat. And this is a great time to, this is a good opportunity to ask Mariatta. Yeah, this is a question I have for you, and maybe I don't know if you can answer it, but as someone that's been in data science, like this is stuff that is like so important to know, but it's not really covered, in school and where we learn it. And I'm just wondering, like, is it part of like programs?
Oh, that's an interesting question. I honestly, it's been a long time since I took courses on this topic. So I did have computer science degree, and honestly, I did not. Again, this was more than 15 years ago. I did not recall that automated testing being covered as part of my degree course. Maybe things have changed recently. I don't know. I got my degree in 2005. I think this topic is emerging for sure. I see lots of books covered unit testing and testing about it. Even I think there was a time even in Vancouver Python Meetup, we talk about testing. Like sometimes we know we need to test, but we don't know how to test. We don't know how to run the test. There's no example about it. Again, not every company actually do this. As I shared in one of the first few companies I work at, we don't test. So there are lots of resources out there, as I shared. Like there are tutorials, talks covered all of this. So yeah.
Yeah, so if anybody has any questions, feel free to post it. I think one of the other things that I have learned from looking at unit tests, because I have been involved in scikit-learn, which is the machine learning library for Python, and it's like you can learn so much about the code by looking at the tests, right? Like what needs to be checked. And also, I don't know if this is related, you could let me know, but these unit tests are also very, very important for, I would say, users. So it sort of throws out errors, right? Like when we try to say put data in, to do like a binary classification or something, but we actually have, let's just say only one class or 100, and it's like no, we're expecting 2 classes. Like that can actually be very helpful to users, right?
Yeah, indeed. Like, what do I say? Especially if it's definitely important. It tells people how the code is meant to be used. For example, if you need certain inputs to your functions or classes, how to set up your class, right? In your unit test, there will be examples on how to set it up. So if you lack actual documentation, unit test is the next best thing to look at to understand how it works. And especially if you open source your projects as a user, when I decide whether I want to adopt your library or not, one of the things I will be looking at is, do you have unit tests? Do you have good coverage? Because one of the reasons we want to rely on open source libraries is so that we don't have to maintain it, but we also want to make sure it's reliable. So having unit tests is a way to make people be confident about your software, that they know you care, you put a lot of care about this, that you put a lot of work to ensuring that it works. It gives them confidence into wanting to use your libraries and your software.
So would you say, I don't know if you can like choose between the two, but would you say like unit tests are even just a little bit more important than documentation? I mean, ideally it's good to have both, right?
It's definitely good to have both, but I've seen projects lacking in documentation, but if they have good unit test coverage, then that's good enough. But ideally, they should have both. I think they serve different purpose though. Like documentation it covers more things, like not just tutorials. It gives you might have how to's, you might have other background context about the project, whereas unit test is more about ensuring the quality of the software, that you actually run every single part of the code, you know what it does, you covered all the different edge cases. So there are two different, I guess the unit test and docs are different. I really recommend having both.
We have a few questions. The first one is, thanks for this useful and very accessible presentation. I'm just getting started on unit tests. Could you give some recommendations on using code editors like PyCharm to write tests?
Yeah, you can definitely run unit tests from PyCharm. I do that myself. I think I don't have time to actually show it right now, but I'm sure they do have tutorials about it. Go check out PyCharm's tutorial. Sorry, I don't have a link right on top of my head right now.
Okay.
But you can totally run unit tests within IDE like PyCharm.
Okay. So then the next question is, I guess you can do it in, say, Visual Studio Code as well, right? Okay.
Yes.
And by the way, what do you use? Do you use PyCharm or Visual Studio Code?
I use PyCharm. I've been using PyCharm for a long time, and at this point, switching to an IDE is a hassle.
Okay.
So like I told people that I can move houses, I can drive different cars, I can move cities, but changing an IDE, I cannot do it.
Okay. That's good. The next question is, are the slides available in your repo? I did share your sample _CI repo in the chat, or the slide is a link to the slides there.
Yeah, I haven't published my slide, but I will. Maybe I can send the link to you later.
Yeah, that'd be great. I will
Yeah.
put it in the description of the video when I load it up, so I could do that.
Mm-hmm.
Yeah. Our next question is, can you explain how to do test-driven development, TDD? Is it similar to unit testing?
Okay, test-driven development is another mindset of development. It's it's kind of different, but you will end up writing unit tests as you do TDD. Basically, the way I would describe TDD is you will be writing your code and your test at the same time. As you start defining your code, you will write your unit test first. You will start making those assertions saying, okay, my code, even though I only defined the function now, I don't have any logic in it yet. You will start defining that. You will start defining the test cases for this. Start creating those assertions before you actually write the logic. Initially, all your tests will fail, but at least you define all those scenarios ahead of time by writing the unit test, and then you implement the code to make sure that this will make the test pass. So that's the test driven development, always thinking about how can this code be tested, always thinking about the test cases of the code. um, that's the best explanation I have. I'm not sure if that helps or not. Does that help?
The person said thank you, so I think the
Yeah.
question the response was helpful.
I thought I should also explain the difference with non-test driven development. Usually the way I do things, I write the code first. I implement the logic. And then when I'm done, I will start writing the test. So test driven is like kind of the reverse of that. Like you write the test first and then you implement the logic. So maybe that's better.
Another question is, the person writes, I noticed in scikit-learn codebase there are several CI spec files set up, for example, for Travis, continuous iteration, and Circle CI. Can you comment on why this may be necessary to use several CI frameworks for one project?
Okay, that's a great question. And even in C Python, we use, I think we still use Travis CI and GitHub Actions at the same time. We might even have Microsoft Azure pipelines as well. And some of the reasons is that sometimes the CI have different, sometimes they provide different environment. Like if you need to run your test in Windows versus in Windows environment versus Unix versus, Mac OS, the different CI providers might have different infrastructure available for you. Additionally, it's for reliability. Sometimes we have seen examples in C Python that Travis CI was down, but we need to continue, and we have the other CI framework as more as a redundancy, like to make sure we can still run it. So it's another way of ensuring your code works in various platforms, basically, for reliability.
That's great. I will probably just wait one more minute and see if anybody else has any questions before I close this out. The best thing to do is to, if you have a question, to put it in the chat, or the Q&A is fine. Yeah, this was very, very, helpful. So just for people who are on the webinar, it's a reminder for people who joined late that this is being recorded and it will be uploaded to the YouTube typically by before the end of the day. So so yeah, definitely I will be sending out an email to the Meetup group. Okay, going once, going twice. Okay. So there are no more questions, and I know you have work to get to. And And so thank you so much for taking the time and doing this presentation. I know you had to prepare a new presentation, and I really appreciate really appreciate that you're doing this for community.
No problem. Thank you so much. Yeah, I do enjoy doing this. It's great. I think it's very important topic, and some things that for some of us we take this for granted. We just we write unit tests, but it's important to be reminded why we need these things.
Yeah,
So
and I definitely will be watching this at least twice to go over all of that, because it's really important material.
Thank you.
Thank you.